Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. By the end of it, I want you to be able to find factors and multiples of a number and understand what we mean when we say prime and composite numbers. So factors go into a number and multiples count up by a number. So let's just look at those first two things. So we're going to start with the number 12 and we're going to calculate its factors and multiples. So the factors of 12 are numbers that go into 12. In other words, when you divide 12 by the number, you get a whole number. So what do I mean by that? Well, 1 is a factor of any whole number because 1 goes into 12 evenly. 12 divided by 1 gives you 12, which is a whole number. 2 is a factor of 12 because it goes into 12. 3 and 4 both go into 12. If you divide 12 by 3, you get 4. If you divide 12 by 4, you get 3. So they go in evenly into 12. 5, however, is not a factor of 12. It doesn't go evenly into 12. You can't times 5 by a whole number to get 12. If you divide 12 by 5, you don't get a whole number. So for all those reasons, 5 doesn't go into 12, and so it's not a factor. 6, however, does go into 12. 7 doesn't, 8 doesn't, 9 doesn't, 10, 11 don't, but 12 does as well. So we stop there because factors of a number are always less than or equal to that number. And that's what this symbol here means, less than or equal to. Whereas it turns out multiples are always greater than or equal to the number. So these are all the factors of 12. So to find factors of a number, unfortunately, when you're doing it in your head or even with a calculator, you just have to count all the numbers less than that number and see which go into it. So factors of 12, just take all the numbers less than 12 and find which of them go into 12. So if I'm going to now look at multiples of 12, so that means we're counting up by 12s. So 12 is a multiple of 12. So we're just counting up by 12s. 12, 24, 36. See, I'm adding 12 each time. And I could keep going because the multiples won't stop. So what do all of these numbers have in common? Well, each of these numbers is divisible by 12. 12 is a factor of each of these numbers. So all the multiples of a number are those divisible by that number. All the multiples of 12 are the numbers that are divisible by 12. Let's look at another number. Let's look at 13. So let's say it's factors. Well, 1 is again a factor. It goes evenly into 13. But 2 doesn't go evenly into 13, nor does 3, 4, 5, and so on. It turns out there are only 2 factors of 13, 1 and 13. So note any number greater than 1 will have at least 2 factors, itself and 1. If they are, however, the only 2 factors, if there's no other factors of a number other than itself and 1, we say that number is prime. Whereas when we were looking at 12, it had heaps of other factors other than itself and 1. It had more than 2 factors. Primes have only 2 factors, whereas composites have more than 2 factors. So whereas 13 is an example of a prime number, 12 is an example of a composite number because it has more than 2 factors. So let's now look at multiples of 13. So once again, we just count up by 13. In other words, we write numbers that are divisible by 13. So 13, then we add 13 again, add 13 again, keep adding 13, and once again, the multiples go on forever. So each of these numbers here is an example of a multiple of 13. So the biggest mistake people make here is mixing up factors and multiples. So remember, factors are always less than the number, multiples always greater than or equal to the number. So if you're looking at, say, factors of 40, you look at numbers less than or equal to 40. If you're looking at multiples of 40, they'd be numbers greater than or equal to 40. So make sure you also understand prime and composite. The biggest mistake people make there, they forget 0 and 1, they're neither prime nor composite. And that's because 1 only has 1 factor, whereas a prime needs to have 2 factors, exactly 2 factors. So how do we actually find prime numbers? Well, we use something called the sieve of Eratosthenes, and that I'm going to show you in another video. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.